Forward in the ever-accelerating world of business, we are drowning in data but starving for insight. For decades, decision-making was an art form guided by experience, intuition, and fragmented information. Then came the revolution of business intelligence, which promised to turn data into a clear narrative. Tools like Power BI empowered a generation of analysts to visualize the past and present with stunning clarity. But a critical question remained: what happens next? This is where the true transformation begins. We are now at the precipice of a new era, where artificial intelligence is not just a buzzword but the essential engine of proactive decision-making. AI provides the missing link, the ability to move from describing what happened to predicting what will happen and prescribing what we should do about it. The AI-Powered Analyst arrives at a perfect moment. This encyclopedia is more than just a technical manual, it is a strategic guidebook for navigating this convergence. It successfully demystifies the complex world of AI and makes it accessible and, more importantly, actionable for the modern business professional. It meets you where you are, whether you are a data analyst looking to add predictive power to your reports, a manager seeking to understand the drivers of your business, or a leader architecting a data-driven culture. The brilliance of this work lies in its practical approach. By leveraging the powerful, yet often underutilized, AI capabilities native to Power BI and its connected cloud services, the authors provide a pragmatic path to value. You will learn not just how to build a model, but how to ask better questions, interpret AI-generated insights with a critical eye, and weave those insights into compelling narratives that drive action. The future of business belongs to those who can harness the combined power of human intuition and artificial intelligence. This book provides the key to that synergy. It is an indispensable resource for anyone ready to stop just reporting on the business and start actively shaping its future. Introduction: the convergence of AI and business intelligence, the new paradigm for decision-making. We have witnessed a dramatic evolution in how organizations use data. The first wave was descriptive analytics. What happened? Powered by reports and dashboards that summarized historical data. This was a monumental step forward, replacing gut feelings with facts. The next wave, diagnostic analytics. Why did it happen? Allowed us to drill down into data to find root causes. Today, we are riding the third and most powerful wave, prescriptive and predictive analytics. The questions are now: what will happen, and what should I do? Answering these questions requires more than just summarizing the past. It requires understanding complex patterns, forecasting trends, and simulating outcomes. This is where artificial intelligence becomes indispensable. AI and machine learning algorithms can detect patterns in data that are invisible to the human eye, providing a crystal ball fueled not by magic, but by math. This book is founded on the principle that the convergence of AI's predictive power with Power BI's intuitive visualization and storytelling platform creates a new paradigm. It enables smart decision-making, faster, more accurate, and more forward-looking than ever before. Who this book is for: analysts, managers, and leaders. This encyclopedia is designed for a broad audience within the modern data-driven organization, data analysts and BI professionals. You will learn how to move beyond traditional reports and embed powerful AI insights directly into your Power BI solutions. This book will elevate your skill set and make you the architect of intelligent decision-making systems. Business analysts and domain experts, if you have deep knowledge of your business, sales, marketing, supply chain, but want to leverage data more powerfully, this book will show you how to use AI visuals and features without needing to be a data scientist. Managers and team leaders, you will gain the literacy required to ask the right questions, interpret AI-driven insights, and manage projects that leverage these technologies. Understand what's possible to better guide your team. Executives and decision makers, this book provides a strategic overview of how integrated AI and BI can create a competitive advantage, foster a data culture, and transform decision-making processes at an organizational level. How to use this encyclopedia. This book is structured as a progressive learning path. Part I builds your foundation in both AI concepts and Power BI mechanics. Parts 2, 3, and 4 are the core of the book, each focusing on a different set of AI capabilities: data preparation, automated insights, and advanced integration. Part V helps you synthesize everything into a strategy and prepare for the future. You can read it linearly from start to finish or use it as a true reference guide, Jumping to the chapters that solve your immediate challenges, look for the practical example and case study boxes in each chapter for real-world applications. Setting up your environment, Power BI and prerequisites. To get the most out of this book, you should have the following ready. 1. Power BI Desktop, the free authoring tool. Download the latest version from https://powerbymicrosoft.com/desktop/ https://powerbymicrosoft.com/desktop/. Ensure you have the necessary permissions to install software on your machine. 2. A Power BI Pro or Premium per user, PPU, license. Many AI features, especially those using the Power BI service, like automated ML and AI insights, require a Pro or PPU license. You can get a free 60-day trial from Microsoft. 3. Sample data sets. We will use various sample datasets throughout the book. The most famous, the AdventureWorks Data Warehouse, is a great starting point and can be easily found online for an open mind. The most important tool. Some concepts may be new, but each chapter is designed to build your knowledge step by step. Let's begin the journey to becoming an AI-powered analyst. Chapter 1, following the structure you provided. Part I, Foundations of AI and Power BI. Chapter 1, Demystifying Artificial Intelligence for the Business Professional. This chapter cuts through the noise and hype surrounding artificial intelligence. Our goal is to build a practical, foundational understanding of what AI is, how it works in a business context, and why it is a transformative tool for any professional, not just data scientists. 11. What is AI? Beyond the hype, artificial intelligence, AI, is a broad field of computer science dedicated to creating systems capable of performing tasks that typically require human intelligence. These tasks include learning, reasoning, problem solving, perception, and understanding language. Moving beyond the science fiction, forget about sentient robots in a business context. Think of AI less as a replacement for humans and more as a powerful tool for augmentation. It's a set of technologies that can automate complex, repetitive cognitive tasks, uncover hidden patterns and insights in vast amounts of data, predict future outcomes based on historical trends, optimize processes and decisions in real time. The hype cycle vs reality. AI is not magic. It is fundamentally a pattern recognition engine built on statistics, probability, and data. The intelligence is derived from data. Without sufficient, high-quality data, AI cannot function effectively. The hype suggests AI can solve any problem instantly. The reality is that it requires careful planning, clean data, and a clear business problem to be effective. Key takeaway: AI is a practical business tool for enhancing human decision-making, powered by data and algorithms, not by magic. 12 key branches of AI: machine learning, deep learning, and natural language processing. The field of AI is vast, but for business applications, 3 subfields are most critical. 1. Machine learning, ML. This is the core of most modern AI applications. ML is the practice of using algorithms to parse data, learn from it, and then make a determination or prediction about something in the world. Analogy: instead of being explicitly programmed to follow rules, an ML model is trained on data. It's like showing a child thousands of pictures of cats and dogs until they can identify new ones on their own. Power BI connection. The automated machine learning, auto ML, and AI visuals in Power BI are almost exclusively powered by ML models. 2. Deep learning, DL. A more complex and powerful subset of ML inspired by the structure of the human brain. Using artificial neural networks, it excels at processing unstructured data like images, sound, and text. Analogy: if ML is a simple flowchart, DL is a massive, multi-layered web of interconnected decisions. It's excellent for very complex patterns but often requires immense computational power and data. Power BI connection. Features like image recognition, e.g., tagging products in images, are built on deep learning models, often from Azure Cognitive Services. 3. Natural language processing, NLP. NLP enables computers to understand, interpret, and generate human language. Analogy: teaching a computer the rules of grammar, context, and slang so it can chat with a customer or summarize a long report. Power BI connection. The Q and A visual is a perfect example of NLP, allowing users to ask questions about their data in plain English. Sentiment analysis of customer reviews is another key application. Key takeaway: ML is the workhorse for business data, DL handles complex unstructured data, and NLP enables human-computer interaction through language. 13 The AI project life cycle, from data to deployment. Implementing AI isn't a single action, it's a disciplined process. Understanding this life cycle is crucial for success. 1 Business problem identification, the most critical step. Every AI project must start with a clear business question, e.g., why are customers churning, or what drives sales in a new region? No business problem, no AI solution. 2 Data acquisition and preparation, often called data wrangling. This involves gathering relevant data from various sources and cleaning it, handling missing values, correcting errors. This is the most time-consuming phase, often taking 70 to 80% of the project's effort. Garbage in, garbage out. 3 Model training and evaluation. This is where algorithms learn from the prepared data. The model is then evaluated on a portion of unseen data to test its accuracy and ensure it can generalize for deployment and integration. A model is useless if it sits on a shelf. It must be deployed into a live environment where it can make predictions on new data. This is where Power BI shines. It allows you to integrate and visualize model outputs directly in dashboards. 5 Monitoring and maintenance. Models can degrade over time as data patterns change, a concept called model drift. They must be continuously monitored and retrained periodically to stay accurate. Key takeaway: AI is a continuous cycle, not a one-off project. Power BI primarily simplifies and integrates steps 2, 4, and 5, making the entire life cycle accessible to analysts. 14 Ethical considerations in AI: bias, transparency, and responsibility. With great power comes great responsibility. Using AI ethically is not optional, it's a business imperative. Bias and fairness. An AI model will learn and amplify any biases present in its training data. If historical hiring data is biased against a certain demographic, an AI screening resumes will perpetuate that bias. It is crucial to audit data and models for fairness, transparency, and explainability. Can you explain why your model made a prediction? A bank can't just tell a customer their loan was denied because the AI said so. Power BI's key influencers visual is a great tool for making AI conclusions more explainable. Privacy and security. AI systems often handle sensitive data. Ensuring this data is anonymized, secure, and used in compliance with regulations like GDPR is paramount. Accountability. Ultimately, humans are accountable for the decisions made by the AI systems they build and deploy. AI is a tool to inform decisions, not to absolve us of the responsibility for making them. Key takeaway: ethical AI is about building trust by proactively addressing bias, ensuring transparency, and upholding privacy. You create AI solutions that are not only powerful but also responsible and sustainable. Chapter 2, following the established structure and tone. Chapter 2, Power BI Primer, the modern data platform. Before we can harness the power of AI, we must master the engine that will drive it. This chapter provides a foundational understanding of the Power BI ecosystem, focusing on the core components that make it an ideal platform for intelligent analytics. Think of this as learning the anatomy of your new superpower. 21 The Power BI ecosystem: desktop, service, and mobile. Power BI is not a single tool but a suite of services and applications that work together. Understanding each component's role is key to a successful deployment. Power BI Desktop, the authoring tool. What it is: a free, feature-rich Windows application installed on your local computer. What it does: this is where the magic of creation happens. You connect to data sources, transform and clean data, build the data model, and create reports and visuals. It is the development environment for all content. Analogy: it's the kitchen where you gather ingredients, prepare the meal, and plate it. Power BI Service, the online platform. What it is: a cloud-based software as a service, SaaS, platform, also known as Power BI Online. What it does: this is where you publish, share, and collaborate on the reports built in desktop. It enables dashboards, single-page collections of key visuals, scheduled data refreshes, app workspaces for team collaboration, and crucially, provides access to many cloud-based AI features. Analogy: it's the restaurant where you serve the meal to your guests. They can interact with it, but they don't need to be in the kitchen. Power BI Mobile, the consumption apps. What it is: native apps for iOS, Android, and Windows devices. What it does: these apps allow users to view and interact with dashboards and reports published to the Power BI service from anywhere. They are designed for touch interaction and on-the-go decision-making. Analogy: it's the takeaway container, allowing your guests to enjoy insights anywhere. Key takeaway: Power BI Desktop is for building, the service is for sharing and collaborating, and the mobile apps are for consuming insights on the move. 22. The Power Query Editor, your data wrangling workbench. Data is rarely clean and ready for analysis. Power Query is the built-in ETL, extract, transform, load tool within Power BI Desktop that is your first and most important step in any analytics project. The Get Data experience: you can connect to hundreds of data sources, from Excel files and SQL databases to cloud services like Salesforce and Azure. The graphical interface: Power Query provides an intuitive, point-and-click interface for data transformation. Each step you take, e.g., removing columns, filtering rows, changing data types, is recorded and saved as a recipe. The M language: behind the scenes, every click generates code in a powerful functional language called M. This recipe ensures your data cleaning process is automated and repeatable the next time you refresh your report. AI-powered wrangling: Power Query includes intelligent features like add column from examples, where you provide a few examples of the desired output, and Power Query uses AI to generate the necessary M code to achieve it for the entire dataset. Key takeaway: Power Query is where you ensure your data is accurate, consistent, and shaped for analysis. Time invested here saves countless hours of troubleshooting later. Clean data is the non-negotiable fuel for AI. 23. Data modeling. 101. Star schemas and relationships. After loading clean data, you must structure it for efficient analysis. A well-designed data model is the backbone of a high-performing Power BI report. The goal: to avoid massive, single tables and instead break data into intuitive, connected tables. This simplifies the model, improves performance, and ensures accurate calculations. The star schema: this is the optimal design pattern. It consists of fact tables. These hold the measurable, quantitative data about business processes, e.g., sales amount, quantity sold. They contain foreign keys that link to dimension tables and are typically very large dimension tables. These hold the descriptive, textual attributes that provide context to the facts, e.g., product name, customer category, date. They contain primary keys and are typically smaller. Managing relationships: you define how these tables connect, e.g., the product ID in the sales fact table links to the product ID in the product dimension table. Power BI automatically detects and creates these relationships, but a savvy analyst always reviews them. Why it matters for AI: a clean star schema ensures that time intelligence functions, filters, and DAX calculations work correctly. AI visuals like key influencers rely on correctly modeled relationships to accurately analyze what dimensions influence a fact. Key takeaway: a well-structured data model, typically a star schema, is not an advanced topic. It is a fundamental requirement for building efficient, accurate, and scalable reports, especially those using AI. 24. Introduction to DAX, Data Analysis Expressions, for Smart Measures. DAX is the formula language used in Power BI to create custom calculations and analysis on your data model. While you can do a lot with clicks, DAX is what unlocks true analytical depth. What it is: a collection of functions, constants, and operators that can be used in a formula to calculate and return one or more values. It looks similar to Excel formulas but is designed to work with relational data and filter context. Core concepts: measures vs calculated columns. A measure is a calculation done on the fly, e.g., total sales equals sum, sales amount. A calculated column is a new column added to a table that is computed during data refresh, e.g., full name equals first name and last name. Filter context: this is the most important DAX concept. It means that a measure's result changes based on filters applied by reports, slicers, or other parts of your formula. A total sales measure will show a different number when filtered by year, region, or product. Essential functions for AI: aggregation, sum, average, count. Filter based calculate, the most powerful function in DAX, used to modify filter context. Time intelligence, totalit, same period last year, Crucial for trend analysis that feeds into forecasting the AI connection, you use DAX to create the metrics you want to analyze. For example, you would create a customer churn flag or measure using DAX logic before using the key influencers visual to analyze what predicts it. Key takeaway: DAX is the language of metrics. Learning its basics is essential for defining the key business outcomes you will later analyze with Power BI's AI tools. Chapter 3, following the structure and expanding on the concepts introduced in the previous chapters. Chapter 3, the seamless integration, how Power BI embraces AI. This chapter is the heart of the book, where the foundational concepts of AI and Power BI converge. We will explore the practical reality. Power BI is not just a visualization tool, it is a democratized AI platform. We will map the various AI capabilities to their locations within the tool, providing a roadmap for the hands-on exploration in the subsequent parts of this Encyclopedia. 31 Overview of AI features native to Power BI. Power BI's AI functionality can be broadly categorized into 3 tiers, each offering a different level of sophistication and user involvement. 1. The low-code/no-code AI. For analysts and business users, these are built-in features that require no background in data science. They are designed for intuitive, click-driven exploration. AI visuals, decomposition tree, key influencers, and Q&A. Power Query AI insights, add column from examples, data profiling, and fuzzy matching. Automated machine learning, AutoML, create and apply predictive models without writing code. To the integrated services AI. For extending capabilities, these features connect Power BI to powerful, pre-built AI models hosted on Microsoft's cloud platform, Azure Cognitive Services. Integrate ready-to-use AI for vision, language, and decision-making, e.g., sentiment analysis, image tagging. Azure Machine Learning, connect to more advanced, custom-built models developed by data science teams. OpenAI Services, leverage large language models for advanced text generation and summarization. 3. The Custom Code AI, for data scientists and advanced users. For maximum flexibility, Power BI allows the integration of custom scripts, R and Python scripts, embed scripts within Power Query for advanced data transformation or within reports to create custom visuals powered by sophisticated algorithms. Key takeaway: Power BI offers a spectrum of AI tools, from intuitive click-to-analyze features for business users to powerful extensibility points for data scientists, all within a unified platform. 32 AI insights in the Power Query Editor. The data preparation phase is where AI can save the most time. Power Query's AI insights transform tedious manual wrangling into intelligent, automated processes. Add column from examples. This is perhaps the most powerful and underutilized AI feature for data transformation. How it works: instead of writing complex M code, you simply provide 1 or 2 examples of the desired output in a new column. Power Query's AI engine detects your pattern and generates the formula to apply it to the entire dataset. Use case: extracting product codes from inconsistent descriptions, combining first and last names with proper capitalization, or categorizing text based on keywords. Data profiling and quality insights. While viewing your data in the Power Query Editor, you get immediate visual cues, like data bars and column quality indicators, that help you identify missing values, errors, and distribution patterns at a glance. This is AI-assisted data discovery. Fuzzy matching, when merging tables from different sources, e.g., customer lists from CRM and ERP systems, names often have spelling discrepancies. Fuzzy matching uses AI to find non-exact matches, intelligently grouping John Smith, John Smith, and John Smith as the same entity. Key takeaway: AI in Power Query is your intelligent data wrangling assistant, automating the most labor-intensive part of any analytics project and ensuring your AI models downstream are built on a foundation of clean, well-structured data. 33 AI visuals for automatic discovery. This is where AI becomes visible and interactive for the end user. These visuals automatically analyze your data to find and explain patterns. Decomposition tree, this visual allows for dynamic, multi-dimensional drill down. Its AI capability: find where this metric is highest or lowest, automatically suggests the most impactful path to take through your data to find the root cause of an anomaly. Key influencers visual: this visual moves beyond correlation to explore causation. It answers the question, What factors are making this metric go up or down? It statistically analyzes all your data fields to rank which dimensions have the strongest influence on a key outcome measure Q and a visual. This is natural language processing, NLP. In action, it allows users to ask questions about their data in plain language, show me sales by country as a map, and instantly get a visual answer. You can teach Q&A to understand your organization's specific terminology. Key takeaway: AI visuals automate the insight generation process. They don't just present data, they analyze it for you, highlighting the most significant trends, drivers, and anomalies without requiring the user to know where to look. 34 Integrating with Azure AI and OpenAI services for specialized tasks beyond automated insights. Power BI seamlessly connects to the broader Microsoft AI cloud ecosystem. Azure Cognitive Services. What it is: a suite of pre-built, pre-trained AI models available as APIs. How it integrates: you can call these services directly from within Power Query Editor. Under AI Insights, you can transform your data using models for text analytics, detect sentiment, extract key phrases, or identify language. Vision: tag images or detect objects. Translation: translate text in columns between languages. Benefit: you get state-of-the-art AI capabilities without needing to build, train, or deploy any models yourself. Azure Machine Learning, AML. What it is: a platform for data scientists to build, train, and deploy custom machine learning models. How it integrates: data scientists can register their custom models in the AML registry through the Power BI data flows integration. An analyst can connect to this model, feed it new data from Power BI, and get predictions back to visualize. OpenAI services. What it is: access to powerful large language models like GPT. How it integrates: using the same Power Query AI Insights connector or a custom M script, you can send data to the OpenAI API to perform tasks like generating summaries for product reviews, classifying support tickets with more nuance, creating dynamic narratives based on data points. Key takeaway: Power BI acts as a gateway to enterprise-grade AI. By integrating with Azure and OpenAI, it allows you to leverage incredibly sophisticated AI capabilities directly within your analytics workflow, making advanced AI accessible to the business analyst. Chapter 4, providing a deep dive into the intelligent data preparation features of Power Query. Part 2, AI-powered data preparation and transformation. Chapter 4, intelligent data wrangling with Power Query. Data preparation is the unglamorous, yet most critical, phase of any analytics project. It is often said that data scientists spend 80% of their time cleaning and preparing data. Power Query, with its integrated AI features, is designed to radically reduce this burden. This chapter explores how artificial intelligence transforms tedious manual data wrangling into an intelligent, efficient, and even insightful process. 41 AI-based column profiling and quality assessment. Before you can transform data, you must understand its state. Power Query provides AI-assisted profiling that gives you an immediate, visual assessment of your data's health and structure directly within the editor. The profile view: when you select a column in Power Query, the bottom of the window displays a preview profile of the data. This isn't just a simple list, it's an intelligent diagnostic tool. Column quality indicator: this feature provides a header above each column showing the percentage of valid, error, and empty values. This is your first and fastest way to identify data completeness issues. Column distribution indicator: this shows a small histogram for numeric columns or a bar chart for text columns, giving you an immediate sense of the data spread, outliers, and common values. For a text column like country, it instantly shows you the frequency of each entry. The AI touch: the system uses statistical analysis to generate these profiles on the fly. It's continuously assessing the data as you apply steps, providing immediate feedback on how your transformations are affecting data quality. Practical application: you can quickly scan a new dataset and identify which columns have a high percentage of missing values that need addressing, which columns contain errors from source systems. The distribution of key metrics: spotting potential outliers or skewness before analysis. Key takeaway: AI-powered profiling provides an at-a-glance health check of your data, moving you from guesswork to a quantified, actionable understanding of data quality issues. 42 The Add column from examples feature: Using AI to write M code. This is arguably the most powerful and user-friendly AI feature in Power Query. It allows you to perform complex data transformations by simply showing Power BI what you want. It then writes the necessary code for you. How it works: 1. You provide one or more examples of the desired output in a new column. 2. Power Query's AI engine analyzes the pattern between your source data and the example. 3. It predicts and generates the output for all rows and creates the underlying M language code to perform the transformation automatically. Why it's revolutionary: it allows users with no programming knowledge to perform incredibly complex text, date, and number manipulations. It democratizes data transformation. Common use cases: text splitting and concatenation. Input: John_Dokes. Example: John Doe. AI learns to replace underscores with spaces and remove the extension. Date parsing. Input: 20240415. Example: 4/15/2024. AI learns to parse YYYYMMDD into a date format. Categorization. Input: laptop, mobile phone, monitor. Example: electronics. After a few examples, AI can categorize the entire product list. Pattern extraction. Input: invoice 12345-2024. Example: 12345. AI learns to extract the numeric invoice ID from the middle of the string. Best practice: always provide 2 to 3 examples to ensure the AI captures the pattern correctly, especially if there are edge cases or inconsistencies. Key takeaway: add column from examples is an intelligent code writing assistant. It translates your intent into action, eliminating the need to learn complex M code syntax for most common transformation tasks. 43. Fuzzy matching. AI for data deduplication and cleansing. Merging data from different sources is a common task plagued by inconsistency. John Smith CO in one system might be Smith John CO in another. Exact matching fails here. Fuzzy matching uses AI to find non-identical but similar text strings. The algorithm: fuzzy matching algorithms, like the jacket similarity or Levenshtein distance, calculate a similarity score between two strings. Power Query allows you to set a similarity threshold to determine what constitutes a match. Where to use it: the primary application is in the Merge Queries dialog. When joining two tables, you can select the Use Fuzzy Matching to perform the merge option. Configurable parameters: similarity threshold, a slider from 000 to 100. A higher value, e.g., 090, requires strings to be very similar. A lower value, e.g., 070, will catch more matches but might include some false positives. Ignore case matches: apple and apple. Ignore character order, can help match strings with transposed words. Maximum number of matches, limits the output to the top n matches per record. Practical application: customer deduplication, identifying and merging duplicate customer records across systems. Product matching, standardizing product names from different suppliers. Data standardization, aligning category names or region names that have been entered inconsistently over time. Key takeaway: fuzzy matching is an essential AI-powered tool for data cleansing and integration. It handles the real-world messiness of data by finding relationships based on similarity, not just exact equality, which is crucial for building a single source of truth. Chapter 5, providing a comprehensive guide to using automated machine learning within Power BI. Chapter 5, automated machine learning, AutoML, for predictive datasets. This chapter marks a significant leap. From analyzing the past to predicting the future, we move beyond descriptive and diagnostic analytics into the realm of predictive analytics. Power BI's automated machine learning, AutoML, feature democratizes this powerful capability, allowing analysts to build, apply, and interpret machine learning models without writing a single line of code. 51. Introduction to automated machine learning, AutoML. What is AutoML? Automated machine learning, AutoML, is the process of automating the end-to-end process of applying machine learning to real-world problems. It automates tasks that are repetitive and time-consuming for data scientists, such as data pre-processing and feature engineering. Selecting the most appropriate algorithm and model architecture, e.g., decision tree, logistic regression, gradient boosting, hyperparameter tuning, optimizing the model settings for performance, model training, validation, and evaluation. Why AutoML in Power BI? Democratization of AI. It puts the power of predictive modeling into the hands of business analysts and domain experts who understand the data and the business problem but may lack a deep data science background. Speed and efficiency. It can evaluate dozens of models in a fraction of the time it would take a human, quickly identifying the best performing one. Focus on value. It allows data professionals to focus on framing business problems and interpreting results, rather than the intricate mechanics of model building. Key takeaway: AutoML is like a powerful, automated factory for creating predictive models. You provide the raw materials, data and a business question, and it delivers a finished, optimized product, a trained model. 52. Creating a predictive model directly in Power BI. Building a model with AutoML is a guided, intuitive process within the Power BI service. Here's a breakdown of the steps. 1. Prerequisites: a Power BI Premium workspace, or a premium per user license, a dataset that is hosted in the Power BI service, not live connected, a clear binary prediction question, e.g., will this customer churn? Yes/no. Will this loan default? Yes/no. 2. The model creation workflow. Identify the table from your dataset, select the table that contains the outcome you want to predict. Choose the target field, select the column you want the model to predict. This must be a column with two outcomes, e.g., churn status with values yes or no. If the column doesn't exist yet, you must create it using DAX or Power Query. First, select related data. Power BI automatically analyzes your data model and suggests related fields from other tables that could be used as influencers. You confirm which fields to include. Run the automation. Power BI AutoML takes over. It splits your data into training and validation sets, runs multiple algorithms, tunes parameters, and selects the best model. Key takeaway: the process is a wizard-driven experience focused on selecting the right data and the business outcome to predict. The complex work of choosing and tuning the model is handled automatically. 53. Interpreting model results, key metrics and validation. Once the model is trained, Power BI provides a detailed report to help you understand its performance and trust its predictions. Interpreting this report is a critical skill. Model Performance Report, AUC, area under the curve, a single number between 0, 5 and 10 that summarizes the model's ability to distinguish between the two classes. 0.8 is good, 0.9 is excellent. This is the primary metric for model quality precision. Of all the records the model predicted as yes, e.g., will churn, how many actually did? High precision means fewer false alarms. Recall, of all the records that actually are yes, how many did the model correctly find? High recall means you're missing fewer true positives. Confusion matrix, a table that shows the actual vs predicted values, giving a clear view of true positives, true negatives, false positives, and false negatives. Feature Importance Report. This is the most valuable part for business insight. It ranks all the factors, columns, that influence the model's prediction by their relative importance. Example, the report might show that days since last login and number of support tickets are the top two influencers for predicting customer churn. This tells you exactly what to focus on to mitigate churn. Key takeaway: a good model isn't just about a high AUC score, it's about understanding why it makes its predictions. Through the Feature Importance Report, which provides actionable business intelligence. 54. Case study, predicting customer churn with AutoML. Business problem: a telecom company wants to proactively identify customers at high risk of churning to target them with retention campaigns. Implementation steps: 1. Data preparation. In Power BI Desktop, the customers table is enriched with a new calculated column called churn, yes/no, based on whether a customer cancelled their service in the last month. This is the target field. The data model includes related tables, service calls, payment history, and subscription plans. 2. Model training. In Power BI service, the analyst navigates to the customer's table in a premium workspace and selects AutoML. They choose the churn column as the field to predict. AutoML automatically includes relevant fields from the customer's table, e.g., tenure, monthly charges, and suggests including fields from related tables, e.g., average call duration, number of late payments from the payment history table. 3. Interpreting results. The model achieves an AUC of 0.87, indicating strong predictive power. The feature importance report reveals the top influencers: 1 tenure, negative correlation, longer tenure equals lower churn risk. 2 number of late payments, positive correlation, more late payments equals higher risk. 3 monthly charges, positive correlation, higher cost equals higher risk. 4 action and integration. The analyst applies the model to the entire customer dataset to get a churn risk score for each current customer. A Power BI dashboard is built showing a list of high-risk customers, filtered by the top influencers. The marketing team uses this dashboard to prioritize outreach, offering tailored incentives to high-risk customers, e.g., a payment plan for those with late payments. Key takeaway: this case study illustrates the complete value chain, from a business problem, through automated model creation and interpretation, to a data-driven action that delivers tangible ROI. AutoML makes this entire process accessible. Chapter 6, following the structure and style of the previous chapters. Part 3, AI Visuals for Automated Insights. Chapter 6, the Decomposition Tree, Root Cause Analysis. The decomposition tree visual is one of the most intuitive and powerful tools for exploratory data analysis in Power BI. It empowers users to break down a single metric across multiple dimensions in an ad hoc manner, dynamically drilling down to discover the root cause of an anomaly or the source of a performance result. Its integrated AI makes this exploration smarter and faster than ever before. 61 When to use the decomposition tree. The decomposition tree is your go-to visual for answering why questions. It is specifically designed for situations where the path to an answer is not linear and requires exploration across various facets of your data. Ideal use cases: root cause analysis, investigating why a key metric, e.g., total sales, profit margin, customer churn rate, is significantly higher or lower than expected. Variance analysis, understanding the factors that contributed most to the difference between a target and an actual result. Ad hoc exploration, allowing business users to freely explore data without a predefined path, following their own line of questioning. Presenting findings, telling a clear data story by showing the step-by-step drill-down path that leads to a core insight. When not to use it: for showing a fixed, predefined hierarchy, use a matrix visual or a chart with drill-down. For comparing multiple metrics side by side, use a bar or column chart. Key takeaway: use the decomposition tree when you need to perform multidimensional, investigative analysis on a single important metric to find the primary drivers of its performance. 62 Drilling down across multiple dimensions with AI guidance. The power of the decomposition tree lies in its flexibility and its AI-powered AI splits feature. Manual exploration: 1. Start with a measure. You begin by adding a core measure, e.g., total sales, to the visuals. Analyze field. 2. Add dimensions. You then add all the dimensions you might want to explore, e.g., country, product category, sales manager, time, quarter, to the explain by field. 3. Interactive drill down. A user can click on any value in the tree, e.g., the total sales bar, and choose any dimension from the explain by list to break it down. For example, you could break down total sales by country, then break down United States by product category, then break down bikes by sales manager. AI-powered exploration, AI splits. This is the visuals killer feature. Instead of manually choosing which dimension to drill into next, you can let AI find the most interesting path for you. How it works: click on a value in the tree and select the find where this measure is high or find where this measure is low option. What it does: Power BI's AI engine instantly analyzes all the dimensions in your explain by field. It calculates which dimension and value contributes the most to making the selected metric high or low at that specific point in the tree. The benefit: it automates discovery. It instantly highlights the most significant contributor to the value you're analyzing, saving you from manually checking every single dimension. It ensures you follow the most statistically relevant path to the root cause. Key takeaway: the decomposition tree combines the flexibility of manual, ad hoc exploration with the power of AI-guided analysis, ensuring you quickly find the most impactful insights without getting lost in the data. 63 Practical example: analyzing sales variance scenario. The sales director opens a dashboard and sees that total sales for the last month are 15% below forecast. She needs to find out why. Step 1. Initial setup. She pins a decomposition tree visual to the dashboard. She adds, analyze, total sales explained by, region, product category, sales representative, month, discount band. Step 2. Starting the investigation. She clicks on the total sales bar in the tree. Instead of guessing, she uses the AI split and selects find where this measure is low. Step 3. AI-Powered Insight. The AI engine analyzes all dimensions and instantly reveals that the primary reason for the overall low sales is the central region. It shows that sales in this region are disproportionately low compared to others. Step 4. Manual drill down. Intrigued, she clicks on the central region bar. She wants to see if this is across all products or specific to one category. She manually selects to drill down by product category. Step 5. Further AI analysis. The tree shows that within the central region, bike sales are critically low, while accessories are normal. She clicks on the bikes category bar and uses the AI split again, find where this measure is low. Step 6. Identifying the root cause. The AI analyzes the remaining dimensions and identifies that the issue is primarily linked to sales representative, Sarah Jones, and a high discount band, high. This suggests that despite offering high discounts, a key sales rep in the central region is significantly underperforming in selling bikes. Conclusion. In less than a minute, the sales director has moved from sales are down 15% to a precise, actionable insight. We need to investigate the sales process and discounting strategy for Sarah Jones in the central region, specifically for bikes. This allows for a targeted intervention instead of a broad, panicked response. Key takeaway. This practical example demonstrates how the decomposition tree, especially with AI splits, transforms a vague business question into a precise, data-driven action plan through a process of intelligent, multidimensional root cause analysis. Chapter 7. The key influencers visual, understanding drivers. While the decomposition tree helps you find where a metric is high or low, the key influencers visual answers the more profound question, why is it high or low? This visual moves beyond simple correlation to perform statistical analysis on your entire data set, identifying and ranking the factors that have the strongest measurable impact on a specific metric you care about. It is one of the most sophisticated AI tools in Power BI for deriving actionable, evidence-based insights. 71. How the key influencers visual works. The key influencers visual uses automated statistical analysis, primarily based on machine learning algorithms like linear regression for continuous metrics and logistic regression for categorical outcomes, to analyze all the data in your model. The core mechanism. 1. You define the question, you select a single field you want to analyze. This is your outcome or target variable, e.g., customer churn, sales amount, production defect rate. 2. The AI analyzes everything. The visual automatically runs an analysis against every other field in your data model that is related or available. It treats each potential field as an influencer or explanatory variable. 3. It calculates impact. For each potential influencer, the algorithm calculates strength of impact. How much does this factor change the outcome? Statistical significance. How confident can we be that this is a real relationship and not just random chance? This is measured by a p-value, which Power BI abstracts away into a clear confidence indicator. 4. It ranks and explains. The visual presents a ranked list of the top influencers. Crucially, it doesn't just show the factor, it explains the direction and magnitude of the influence, e.g., tenure is a key influencer when tenure is 1 year, the probability of churn is 35% when tenure is 3 years, the probability drops to 12%. Key takeaway, the key influencers visual automates complex statistical modeling to provide a clear, ranked, and explainable list of what truly drives your key business outcomes. 72. Analyzing what influences a metric. Continuous variable. A continuous variable is a numeric value that can be measured on a scale, like sales amount, age, temperature, or processing time. How the visual behaves. When you choose a continuous field as your analyze field, the visual answers the question, what factors make this number go up or down? Output. The Key Influencers tab will show you which categories or numeric ranges are associated with higher or lower values of your metric. Example, Analyzing sales amount, the visual might find, product category is an influencer bikes have an average sales amount $1,200 higher than the overall average, or, customer age is an influencer customers in the 35 to 44 age group have an average sales amount $500 higher than the overall average. Interpreting the results, look for the factors that have the largest absolute effect on the metric. The visual will display the average value of your metric for a specific segment and compare it to the overall average. Key takeaway: use this for optimizing performance. If you want to increase sales amount or decrease handle time, this visual tells you which segments to focus on or avoid. 73. Analyzing what influences a category. Categorical variable. A categorical variable represents types or classes, like churn status, yes/no, product purchased, product A, B, C, or survey response, satisfied, neutral, dissatisfied. How the visual behaves: when you choose a categorical field as your analyze field, the visual answers the question, what factors make someone or something more likely to be in this specific category? Output: you must select a specific value to analyze, e.g., churn equals yes. The Key Influencers tab will then show you which factors make that outcome more or less likely. Example: analyzing churn equals yes, the visual might find, number of support tickets is a top influencer. Customers with more than 5 support tickets are 28x more likely to churn, or, subscription type is an influencer. Customers on the basic plan are 40% less likely to churn than average. Interpreting the results, the visual uses likelihood and probability, which are intuitive for business users. A result showing 4x more likely is a very strong, actionable signal. Key takeaway: use this for predicting and preventing outcomes. It's perfect for understanding the drivers of customer churn, product choice, campaign conversion, or defect rate. 74. Case study: identifying key influencers for product purchases. Business problem: an e-commerce company wants to understand what factors most influence a customer's decision to purchase a high-margin premium widget instead of a standard one. This will help them target their marketing efforts more effectively. Implementation in Power BI. 1. Data setup. The dataset includes customer demographics, website behavior, and purchase history. A calculated column flags each transaction as premium widget or standard widget. 2. Configuring the visual. Analyze. Product type. This is the categorical outcome, explained by all related fields like customer age, income band, time on page, previous purchases, marketing channel, region. The analyst selects the value premium widget to analyze. 3. Interpreting the results. The Key Influencers visual generates a clear report. Top influencer 1, income band. Customers in the $100K and income band are 5x more likely to purchase a premium widget. Top influencer 2, time on page. Customers who spent more than 3 minutes on the product page are 1x more likely to purchase a premium widget. Top influencer 3, marketing channel. Customers arriving from affiliate blog review are 50% more likely to purchase a premium widget. 4. Actionable insight and decision. The marketing team uses these insights to refine their strategy. Targeting. They allocate more of their ad budget for the premium widget to target audiences within high-income brackets on social media and premium websites. Website optimization. They focus on improving the product page content and user experience to increase engagement time for all users. As this is a strong indicator of purchase intent. Partnerships. They decide to invest more in the affiliate blog program, which is proven to drive high-value customers. Key takeaway: the Key Influencers visual transformed raw customer data into a precise marketing playbook. It moved the team from guessing which factors were important to knowing which ones mattered most and by how much, enabling a highly efficient and data-driven strategy. Chapter 8, the Q&A visual, natural language. Querying. The Q&A, question and answer, visual represents the pinnacle of user-friendly analytics. It allows users to ask questions about their data in their own words and instantly receive answers in the form of visuals. This is natural language processing, NLP, in its most practical and empowering form, breaking down the final barrier between business users and the insights hidden in data. This chapter covers how to set up, train, and deploy this powerful feature. 81. Setting up the Q&A engine for your data model. The Q&A engine doesn't work by magic. It relies on a well-structured data model to accurately interpret questions. The setup begins long before you add the visual to a report. Foundational requirements. 1. A clean data model. This is the most critical step. Q&A works best with a well-modeled star schema. Clear table names. Use intuitive names like sales, products, and customers instead of TBL_fact_123 or sheet 1. Clear column names. Use spaces and readable names like product category and unit price instead of prodcat or COLX. Explicit relationships. Properly defined relationships between tables allow Q&A to correctly navigate from a fact, e.g., sales, to a dimension, e.g., customer geography, to measures and synonyms. Create measures. Define important calculations with DAX, e.g., total sales, YTD revenue, customer count. This teaches Q&A the precise definition of these terms. Add synonyms. In the model view of Power BI Desktop, you can select a table or column and add synonyms in the Properties pane. For example, for a sales amount column, you could add synonyms like revenue, income, sales, and takings. This helps Q&A understand different ways users might refer to the same concept. Key takeaway. A well-structured data model with intuitive names and defined relationships is the essential foundation for an accurate and useful Q&A experience. 82. Teaching Q&A to understand your business terminology. Every organization has its own unique jargon. Q&A can be trained to understand this specific terminology, making it even more powerful. The Teach Q&A feature. 1. In the Power BI service, after you publish a report, you can access a dedicated Teach Q&A interface for the dataset. 2. Providing examples. You enter phrases that users might ask and then manually select the visual or field that should be the correct response. Example, you might teach Q&A that the question "how many heads do we have?" should return a card visual for the employee count measure. Example, you could teach that "show me our top SKUs" should create a bar chart of product name by total sales, sorted descending. How it learns. This process does not retrain the core NLP model. Instead, it creates a mapping between your organization's specific terms and the underlying elements, tables, columns, measures, in your data model. It's essentially building a custom dictionary for your dataset. Key takeaway. Proactively teaching Q&A ensures it understands company-specific slang and acronyms, dramatically improving the user experience and adoption rate. 83. Best practices for effective natural language queries. To get the best results, users should be guided on how to ask questions effectively. Tips for users. Start broad, then refine. Begin with a simple question like total sales by year and then add more detail, total sales by year and product category for last year. Use column names. The most reliable results come from using the names of tables and columns in the model, e.g., show customer satisfaction by support agent. Leverage auto-suggest. As you type, Q&A provides suggestions. Use these to guide your query and ensure you're using terms the system recognizes. Specify chart types. You can often request a specific visual type, sales by month as a line chart, market share as a pie chart, or top customers as a table. Common pitfalls to avoid. Overly complex questions. Avoid long, run-on sentences with multiple clauses. Break them into separate questions. Vague language. Questions like "show me everything" or "what's wrong" are too ambiguous for the system to interpret. Negations and humor. The engine can struggle with sarcasm, negations, "show me products that are not performing well," or subjective language. Key takeaway. Effective Q&A is a dialogue. Users get the best results by using clear, model-aware language and leveraging the system's suggestions to refine their questions. 84. Embedding Q&A in reports for end-user exploration. The Q&A visual isn't just for standalone use, it's most powerful when embedded as a natural exploration tool within your published reports. The Q&A visual. 1. Adding to a report. In Power BI Desktop, you can add the Q&A visual just like any other visual. You can resize it and format it to fit your dashboard layout. 2. Pre-configuring questions. Report designers can preload the visual with a suggested question to prompt users, e.g., try asking, "What is sales by region?" 3. The Q&A button. A smaller Q&A icon can be added to a report page, which expands into the full Q&A experience when clicked. Saving dashboard space. Creating a Q&A exploration page. A best practice is to dedicate a full report page to the Q&A visual. Add instructions, include text boxes with tips and examples to guide users. Pin important visuals. You can pin key visuals, like a top influencer's visual for sales, to this page to give users a starting point for their exploration. Enable cross-filtering. Ensure that when a user creates a visual via Q&A, it interacts with other visuals on the page, maintaining a cohesive analytical experience. Case study, empowering a sales team. A national sales manager has a dashboard with summary KPIs. By embedding a large Q&A visual on the page, they can instantly ask follow-up questions without needing to request a new report from IT. Which products are driving the increase in the central region? Show me a trend of sales for customer segment A versus B. Who are the top 5 sales reps for product X this quarter? This empowers them to find their own answers instantly, fostering a truly data-driven culture. Key takeaway, embedding Q&A directly into reports transforms static dashboards into interactive conversational platforms, enabling endless self-service exploration and accelerating the decision-making cycle for all users. Chapter 9, focusing on the practical integration of pre-built AI models into the Power BI workflow. Part 4, advanced integration and custom AI. Chapter 9, leveraging Azure Cognitive Services in Power BI. This chapter moves beyond the AI capabilities native to the Power BI interface and into the vast ecosystem of Microsoft Azure. Azure Cognitive Services provide pre-built, state-of-the-art AI models that can be called as APIs. Power BI's deep integration with these services allows you to infuse your data preparation process with advanced AI for text, vision, and language, transforming raw, unstructured data into actionable, structured insights. 91. What are Azure Cognitive Services? Azure Cognitive Services are a collection of cloud-based APIs, SDKs, and services designed to make applications more intelligent, engaging, and discoverable without requiring direct AI or data science expertise. Core principles, pre-built and pre-trained. Microsoft has already built, trained, and optimized the underlying machine learning models on massive datasets. You don't need to provide training data or manage model training. You simply send your data and get a result accessible via API. The functionality is consumed through simple REST API calls, making it easy to integrate into applications. Power Query in Power BI provides a user-friendly interface for these calls categorized by function. The services are grouped into 5 main domains: 1. Vision, image processing, recognition, and analysis. 2. Language, natural language processing, understanding, and translation. 3. Speech, speech to text, text to speech, and speaker recognition. 4. Decision, content moderation and anomaly detection. 5. OpenAI, access to powerful large language models like GPT-4. The Power BI connection. This integration happens primarily within the Power Query editor under the AI Insights menu. You can connect to your Azure account and apply these cognitive services as a data transformation step, enriching your dataset as you shape it. Key takeaway, Azure Cognitive Services are ready to use AI building blocks. Power BI acts as a conduit, allowing you to apply these powerful models to your data during the ETL. Extract, transform, load, process. 92. Sentiment analysis, gauging customer opinion from text. What it is, the Text Analytics API can evaluate text and score the sentiment on a scale from 0, highly negative, to 1, highly positive. It detects positive, negative, neutral, and mixed sentiments. Power BI use case, analyzing unstructured text feedback from sources like customer reviews and surveys, social media mentions, support ticket comments, call center transcripts. Implementation steps in Power Query. 1. Get data, import a table containing text fields, e.g., a CSV of product reviews with a comment column. 2. AI Insights, select the text column, then go to Add Column. AI Insights detect sentiment. 3. Authenticate, connect to your Azure resource by providing your account key and endpoint URL. 4. Configure and run, Power Query will send the text data to the Azure service and return a new column with the sentiment score for each row. Result and analysis, you now have a structured, quantitative field, sentiment score, that can be used for analysis, Create a dashboard to track average sentiment score over time. Use the decomposition tree to find out which products have the lowest sentiment. Correlate low sentiment scores with other factors like product category or support agent using the key influencers visual. Key takeaway: sentiment analysis turns subjective, qualitative text into an objective, quantifiable metric, enabling you to systematically track and analyze customer opinion. At scale 93 Image tagging, automatically cataloging product images. What it is: the computer vision API can analyze images and return a list of content tags based on objects, actions, and contexts identified in the image. Power by use case: automating the categorization and searchability of visual assets, product image catalogs, e.g., tagging images with outdoor, shoe, blue, running, social media. Photo analysis: quality control in manufacturing, e.g., identifying damaged goods from images. Implementation steps in Power Query: 1. Get data: import a table containing URLs pointing to images, e.g., a product list with an image URL column. The images must be accessible online. 2. AI Insights: select the column with image URLs, then go to Add Column. AI Insights tag images. 3. Authenticate: connect to your Azure Computer Vision resource. 4. Configure and run: Power Query will send each image URL to Azure and return a new column by default. This column is a structured list of records containing the tags and their confidence scores. Transforming the results: use Power Query's Expand button to transform the structured list into new columns, e.g., Tag 1, Tag 2, Confidence Score 1, etc. You now have a searchable, categorized catalog. Result and analysis: create a report where users can filter products by these auto-generated tags. Analyze which visual product features, tags, are most common among your best-selling items. Key takeaway: image tagging automates the tedious and subjective process of manually categorizing visual content, unlocking insights from a previously untapped data source. 94 Text translation: breaking down language barriers in global data. What it is: the translator service can instantly translate text between over 100 languages. Power by use case: standardizing text data from global operations, translating customer feedback from various languages into a single, common language, e.g., English, for unified analysis. Translating product descriptions or categories from legacy systems into a new standard language. Preparing data for natural language processing, like sentiment analysis, that requires a specific language input. Implementation steps in Power Query: 1. Get data: import a table containing text in multiple languages, e.g., a global survey with a comment column. 2. AI Insights: select the text column, then go to Add Column. AI Insights translate. 3. Authenticate: connect to your Azure Translator resource. 4. Configure: a dialog box will appear. You must specify the destination language, e.g., and for English, you can optionally tell the service the source language if you know it, or leave it to auto-detect. 5. Run: Power Query will translate the text in each row to the target language, adding a new column with the translated result. Result and analysis: you now have a unified translated comment column where all text is in a single language. This column can now be used for sentiment analysis, as described in 92, analyzed with the Q and a visual read and understood by analysts across the company. Key takeaway: the translation service removes language as a barrier to global data analysis, allowing you to consolidate and derive insights from text data collected anywhere in the world. Chapter 10: Integrating OpenAI and Azure OpenAI models. This chapter explores the cutting edge of AI integration in Power BI, leveraging the power of large language models, LLMs, like GPT. This moves beyond analytical AI into the realm of generative AI, allowing you to not just analyze data but to synthesize it, summarize it, and create dynamic, conversational interfaces directly atop your datasets. This represents a paradigm shift from static reporting to interactive, intelligent data storytelling. 101 Introduction to Large Language Models, LLMs, like GPT. What are LLMs? Large language models, LLMs, are a type of artificial intelligence trained on a massive corpus of text data. Unlike traditional models designed for a single task, e.g., prediction or classification, LLMs are foundation models capable of a wide range of language-related tasks, including writing, summarizing, translating, and answering questions, all based on the patterns they learned during training. Key concepts: generative AI, LLMs generate new, original content, text, code, etc., based on the input they receive, rather than just making a prediction or classification. Prompt engineering, the art and science of crafting instructions, prompts, to guide the LLM to produce the desired output. The quality of the output is highly dependent on the quality of the prompt. GPT, generative pre-trained transformer developed by OpenAI. GPT is one of the most well-known LLM architectures. It predicts the next most likely word in a sequence, allowing it to generate coherent and contextually relevant sentences and paragraphs. Azure OpenAI Service, Microsoft's enterprise-grade service that provides access to OpenAI's powerful models, like GPT-4, with the security, compliance, and integration benefits of the Azure cloud. Key takeaway: LLMs are not analytical engines, they are reasoning and content generation engines in a Power BI context. They are used to add narrative, context, and conversational interfaces to your data. 102 Connecting Power BI to the OpenAI API. To use an LLM, Power BI needs to communicate with either the OpenAI API or the Azure OpenAI service. This is achieved through Power Query's ability to call web services. Implementation steps: 1. Obtain API access. OpenAI, create an account on platform OpenAI.com and generate an API key. Azure OpenAI, apply for access through your Azure portal. This is the preferred method for enterprise use due to its data privacy and security commitments. To create a custom function in Power Query, code. You will write a custom function that takes text as an input, structures a prompt, and sends an HTTP request to the chosen API endpoint. The function must include the API key in the request header for authentication. It will then parse the JSON response returned by the API to extract the generated text. 3. Invoke the custom function. You apply this custom function to a column in your table, e.g., a column of product reviews. For each row, the function sends the text to the LLM and returns the result, e.g., a summary of the review, into a new column. Important considerations: cost. API calls are not free and are billed per token. A token is roughly a word fragment. Be mindful of the volume of data you process. Data privacy: never send sensitive, personal, or confidential data to the public OpenAI API. Use Azure OpenAI for enterprise data, as it provides data governance guarantees performance. Each API call takes time. Invoking this on a very large table, millions of rows, can be slow and expensive. Key takeaway: integration requires writing custom code to call the API, making it an advanced but highly powerful technique for data enrichment. 103 Generating summaries and narratives from data. This is one of the most impactful use cases for LLMs in Power BI, turning raw data and metrics into human-readable narratives. How it works: you craft a prompt that instructs the LLM to act as a data analyst and write a summary based on the data you provide. Example: automated report summarization scenario. A table contains daily KPI data for a store, date, total sales, customer count, top selling product. Prompt engineering: your Power Query function would send a prompt for each row, each day, that looks like, act as a retail data analyst in one concise sentence. Summarize the performance for date data, total sales, total sales, customers, customer count, top product, top selling product. Highlight any significant deviations from average result. The new column would contain generated text like: April 15th saw strong performance with $15,000 in sales, 20% above average, driven by high demand for mountain bikes applications. Automating commentary: generate executive summaries for weekly reports explaining anomalies. Create automatic descriptions for data points flagged as outliers. Product descriptions: generate SEO-friendly descriptions from a list of product attributes. Key takeaway: LLMs can automate the final mile of analytics, the narrative, transforming cold numbers into insightful Actionable summaries that are instantly understandable. 104 Creating a dynamic chatbot for your dataset. This technique combines the power of the Q and a visual with the linguistic flexibility of an LLM to create a more robust and conversational data exploration tool. Concept: instead of just translating a natural language question into a DAX query, like the standard Q and a visual, you use an LLM to act as an intelligent intermediary. The LLM can understand more complex, nuanced questions and generate the appropriate query or even a narrative response. Implementation architecture: one user asks a question in a custom-built Power BI report text box, using a third-party visual or Power Apps. 2. The question is sent to the LLM API along with context about the data model, e.g., a list of table and column names. 3. The LLM is prompted to generate either a DAX query to answer the question, which is then executed against the dataset, or a narrative answer based on its understanding of the data. Schema and typical metrics for the response: either a visual from the DAX query or text from the LLM, is displayed to the user. Example prompt for the LLM: you are an assistant for a Power BI dataset about sales. The dataset has these tables: sales, amount, quantity, products, name, category, customers, country. Translate the following user question into a valid DAX query question: what were the top 3 products in Canada last month by sales amount? Only return the DAX code. Benefits over standard Q&A: handles ambiguity, can ask how did we do last quarter, and the LLM can infer that how did we do likely refers to total sales or profit. Complex queries: can handle multi-step questions that would break the standard Q&A engine. Narrative responses: can answer why questions by generating a summary instead of just a chart. Key takeaway: while complex to set up, an LLM-powered chatbot creates a truly conversational analytics experience, allowing users to ask questions of their data with the same flexibility they would use with a human expert. Chapter 11: Advanced Analytics with R and Python Scripts. This chapter is for the data analyst ready to transcend the click and point interface and wield the full, customizable power of the data science ecosystem. While Power BI's built-in AI features are powerful, they can be limiting. By integrating R and Python scripts, you can incorporate any statistical model, machine learning algorithm, or visualization library directly into your Power BI workflow. This chapter unlocks a universe of advanced, custom analytics. 111 Enabling R and Python scripting in Power BI. Before you can run any code, you need to set up your environment. The process is similar for both R and Python. Prerequisites: 1. Install the languages. You must have R or Python installed on the same machine as Power BI Desktop. For R, it's recommended to install from https://www.rprojectorg/ https://www.rprojectorg/ and use an IDE like RStudio. For Python, the simplest method is to install the Anaconda distribution, https://wanaconda.com/download, which includes most essential data science libraries, pandas, scikit-learn, matplotlib, etc., and a package manager to configure Power BI Desktop. Open Power BI Desktop, go to File Options and Settings option, select Python scripting or R scripting from the menu on the left. Point Power BI to your local Python or R home directory, e.g., c/users/ your user /Anaconda3 for Python, or c/program files /r/r431 for R. How it works: Power BI doesn't run the languages internally. Instead, it sends a data frame, a table, of data to your local R or Python installation, executes your script, and expects to receive a transformed data frame back. This happens in 2 places: 1 in Power Query Editor, for advanced data transformation; 2 as a custom visual, to create plots that are not available natively in Power BI. Key takeaway: Power BI acts as a conductor, orchestrating the flow of data to and from your local R or Python engine, allowing you to leverage their immense libraries for specific tasks. 112 Building custom forecasting models with Profit, Python. While Power BI has a built-in forecast feature, it is relatively basic. Facebook's Profit library is a robust, Scalable forecasting procedure designed for business time series data that handles seasonality, holidays, and trends exceptionally well. Why profit? It is more intuitive and often produces better results on business data than traditional ARIMA models, with less need for expert parameter tuning implementation steps. 1. Prepare data in Power Query. Your data must be shaped as a time series. One date time column and one numeric value column ensure there are no future dates you want to forecast. To run a Python script in Power Query, select the table with your time series, go to Transform, Run Python script. A dialog box appears. Write a script that imports the necessary libraries, pandas, profit, renames the columns to the profit standard DS, date stamp, and Y, value, creates and fits a profit model, generates a future data frame for the number of periods you want to forecast, makes the forecast and returns a data frame with the forecasted values, including uncertainty intervals. Python Power BI automatically generates this line: dataset equals pandas data frame, sales underscore table, import pandas as PD from profit, import profit. Prepare the data for profit. df equals datastre name, columns equals date, ds, sales amount, y, create and fit the model. Model equals profit, interval underscore width equals 0.95, 95% confidence interval. Model fit, df, create a data frame for future 365 days. Future equals model make underscore future underscore data frame, periods equals 365, frequency equals d, forecast equals model predict, future, return only the relevant columns, date, forecast, and uncertainty intervals. Output underscore df equals forecast ds, yhat underscore lower, yhat underscore upper. 3. Integrate the output, click OK, and Power Query will show the resulting data frame. You can then expand it and merge it with your original data to visualize historical vs forecasted values in your report. Key takeaway: using Python scripts with profit allows you to implement state-of-the-art, highly customizable forecasting directly within your ETL process, far surpassing the capabilities of the native forecasting feature. 113. Performing advanced cluster analysis, unsupervised learning, clustering, e.g., k-means, hierarchical, is a type of unsupervised learning used to find hidden patterns or groupings in data. Power BI has no native visual for this, making r/Python scripts essential. Use case: customer segmentation based on purchasing behavior, e.g., frequency, recency, monetary value. Implementation steps: using Python and scikit-learn. 1. Prepare data in Power Query. Create a table with the metrics you want to cluster on. Crucially, standardize/normalize the data, e.g., using table transform columns in M or within the script itself, as clustering algorithms are sensitive to scale. To run a Python script in Power Query, the script will import sklearn for clustering and pandas. Perform k-means clustering on the selected columns. Add a new column to the data frame indicating the cluster label for each row. Python dataset is provided by Power BI. Import pandas as PD from sklearn cluster. Import k-means from sklearn. Pre-processing. Import standard scalar. Scale the data. Scalar equals standard scalar, scaled underscore data equals scalar fee underscore transform, dataset total sales, order count, days since last order. Perform k-means clustering, assuming 4 segments, k-means equals k-means, n underscore clusters equals 4, random underscore state equals 0, clusters equals k-means fit underscore predict, scaled underscore data. Add the cluster labels back to the original data frame. Dataset customer segment equals clusters. Output the enhanced data frame. Output equals dataset. 3. Use the result. The output table now has a customer segment column, e.g., 0, 1, 2, 3. You can load this table and use it in your report. Just like any other field, build visuals to analyze the characteristics of each cluster. What defines a high-value customer vs a at-risk customer? Key takeaway: scripting enables unsupervised learning techniques like clustering, allowing you to discover entirely new, data-driven categories and segments within your data that are not predefined. 114. Creating custom visuals with Python libraries like Matplotlib. Sometimes the native Power BI visuals or those in AppSource aren't enough. Using Python visuals, You can create highly specific, publication quality plots. How it works: you add a Python visual to a report page, you drag the fields you want to use into the visual's values, Power BI sends that data to Python and runs your script, which must generate a plot using a library like Matplotlib or Seaborn. Example, creating a detailed correlation matrix heat map. 1. Add a Python visual to the canvas. 2. Drag all the numeric fields you want to correlate into the values field of the visual. 3. Write a script to calculate correlations and plot a heat map. Python. The dataset variable is a pandas data frame containing the fields you dragged in. Import matplotlib pyplot as plt, import pandas as pd, import numpy as np, import seaborn as sns. Calculate correlations. CORR equals datasetker, generate a mask for the upper triangle. Mask equals entry npens underscore like, CORR, type equals bool, set up the matplotlib figure f, ax equals subplots, fig size equals 11, 9, generate a custom diverging color map. Map equals tins diverging underscore palette, 230, 20, as underscore map equals true. Draw the heat map with the mask and correct aspect ratio. Tin sheet map, CORR, mask equals mask, map equals map, vmax equals 3, center equals 0, square equals true, line widths equals 5, spar underscore kws equals shrink, 5, anot equals true, pltitl, feature correlation matrix, pltite underscore layout, ensures labels aren't cut off. Show